means it have the single. What exactly the camera it have? So the sensor, and the sensor will process the data to the controller, and the controller will make the decision. Okay, so whether you need to apply the brakes or you need to control the steering. So that decision will be taken once based upon the input. Okay, so how the camera frames will be transferred? So like consider I have a camera. Okay, so the camera senses camera sensor we have. Okay, so it will take the analog information. Okay, so this is a kind of a camera lens where we can see, but inside lens we have a camera. Okay, so means like consider this is outside the camera, and means the lens we have, and we have the sensor. So this sensor is nothing but the CMOS sensor. So it will take the data, whatever the analog information it is taking, right? So that analog information will be in a form of square waveforms, right? We usually have. So this will be taking. So how this data will do? So this data, this CMOS will convert all the analog information to the in the form of frames. Okay, so individually it have the single frames. Consider like you take one snap in your mobile. So one image, it will be appearing like a frames in it. Okay, so the frames, it one frame it carries one bit. This is example. Okay, so one frame. So like this is two, this is three, this is four, 5, 6, 7, 8, 9, and 10. Like that, the frames. But for one image, it will come around 100 bits. Sometimes, whenever you save the image, right, or the pic, so you can see that it is will be storing as a part of a KB or MB. Means whatever the image we are capturing it, so that image will be taking in the form of frames. Is it clear? Means that is a pixels, what we say as a pixels. Okay, so means that frames will be converted to pixels, and pixels we are able to see on the um, window. Okay, so on the image, the backend it will be the pixel part. So is it clear, right? So next is a part of how this video, whatever the data analog input we are converting it. So that data will be encoded to the format. Okay, so the it means into the frames, and each image, no, whatever the image, but how you are getting the video. So any video, it will be captured in the form of images. Okay, so whenever you play these images will be played in terms of video. Getting right? The videos are whatever the movies or anything, the digital play, it all will be captured in the form of images, and that images when you it will be in a order, so one after another, that images will be playing back. Okay, so that means that images will be in a order that will be played. So mostly you can see these images as a video. Okay, so that each image, like if you say you have a one video, that video size is 50 MB. Okay, so each here 50 MB means one image, it consists of like 5 images. You can say these 5 images, you have a hello. It's some one person say come and say within 5 seconds hello. Okay, so that is the video. For that, the person here, first the person will be appear, and he will take a movement of hand in the next image. This is the first image. This will be the second image, and next third image will be there. So it will come as the hello, and he will raise the hand down. Means like that, the images will be framed. Okay, and it will be played as a video. So this is about exact whatever the images it will be captured by our camera. It will be around 300 kb. Okay, so this is one important, and one frame generally, whatever are the frame we are capturing, right? So it is about 300 kilobytes. And why whatever the data at one time it will capture around 1 to 100 bytes of data. Okay, so what is this information? You know about bytes and bits, right? So if it is a 1200 bytes, what is the bits in it? Into 8, right? Is it
The
is it okay, right? This is a this many bytes of data that we're transferring. Okay. So if you count it, you will get the answer. So here 300 into 1000 is 250 frames. That is one image it is capturing. Okay, just small calculation for this. And whatever FBS means frames per second. Okay, frames uh, per second. So that will be the FBS video, and 15 images will be captured for every second, because whenever you are playing the video, the image capturing should be a faster. Okay, if it is slower means you cannot access the data. So for every 1 second, if you see 1 second, you need to play the video. At least 5 images should be captured at a time, 5 or 10 images. If you it is a more accuracy, you need to take more images. Okay, it will be like that. It is clear, right? How the sensor of the camera will take the information, the frames and bits. Is it clear, or still you have any doubt?
no.
So each image, okay, each whatever the image you are taking, that image contains pixels. Okay, so that all like frames, all like it is a one small bit. Okay, so that bits are forming into the, here we say as a frames. That frames we are capturing in the form of image. Okay, so all frame pixels means whatever the image, small pixels will be there, so that will be combined, we call as a image. Okay, so these images, so multiple images will be framed as a video. Okay, so that video will be encoded. So okay, so still now you are clear like how the sensor is reading the information. Now, once sensor reads the information, okay, so what is the next step I need to do? So once the sensor reads the information, okay, so this information will be in an analog, we know. So it will convert this analog to digital converter. Okay, so then it will go to the video processor. Okay, so now to add some video or like audio and all, so you have specifically the audio sensor will be there. So it will read the your voice, and it will be giving directly to the processing phase. Okay, means it is a part of a syncing. Okay, so for that the syncing will be there. Sorry, so the sensor and ADC, and we have a syncing. Okay, so parallelly the audio video when you are capturing, right? So here video image will be capturing, and here you have a sensor of audio, so that it will be capturing, and this is a syncing phase. It will sync together and will be converting this ADC, and it will going to the processor. So once this processor is done, so then whether if any object is there here, so that we can see as a part of display, we can see in a display unit. And moreover, if you because as a part of ADAS feature, if object is there, you need to stop the vehicle. So in that case, you need to apply the brake and stop the engine. So that is what the action steps you will do it. That is the decision making. Uh, you will do as a part of a action. Is it clear? So this is how. the steps we are doing as part of camera. Okay, and last section we saw about how this DSpace and control desk automation we have, and there what are the tools we are using, and how we are able to see the vehicle and visually, and that information we are giving to the hill, and it will throw from hill the signals you will give with the help of the harness you are connecting to the camera, and the video play will be there, so that is projected, so that you are doing an hill testing. So in case if there is a no hill, how you are doing? So here if there is a no hill, so just you are connecting the controller with the help of cancase excel, and with camera camera is a sensor, okay, don't, and next this sensor is connected to the ECU. Interview they may confuse you. Okay, camera is a sensor or ECU. So it is a camera sensor is there. Okay, camera is a sensor, and it have integrated with the ECU, like that you need to say. And we have a canoe. So what under we'll do? We'll do the signals testing. So like signals related TX and RX messages, and timeout related we'll do this, and we'll do the diagnostics related testing. So UDS kind of thing, and some part of an initial value and cycle value. Okay, so maximum minimum value. So this one all we'll be doing as a part of a signal testing. Is it clear, right? So how you are doing on hill bench and how you are doing on, this is a part of the open loop bench setup, open loop system, and that you are doing on the so single ECU testing. Okay, hope you are clear. So let's discuss some more points. Um, so this is about how we are supplying the 12 volts to the controller, and it have the camera, so the data will be analog, it will be capturing and it will processing, so then output will be taking place. Okay, so how this processing will be happening, uh, this is one schematic diagram. So just we have integrated mono camera, we can use stereo camera and multi camera. Okay, so where the sensor will read the information, and it will process the data, and based upon this the output will be decided. Okay, so and we have the switches also, because whenever the camera is there, that time you need to remove the fog, means due to the fog or dust, if the camera is blocked, that you need to remove it. So we have a defogger, that is a switch where it will allow to clean the camera. And the other thing, it will act the output, and the ADAS features will be enabled. Means how these features are enabled. So generally, the ADAS is one sensor. Okay, so here we can see the camera is connected with here one controller, and it will give to the it is interfaced to one of the microcontroller, that is a ADAS ECU. So that ADAS ECU is a one master ECU, where this with the help of this we can see the warnings, and action steps will be followed. It will decide the action. So that's how the ADAS features will be integrated, and it will work together. Okay. So hope you are clear on this camera. And what are the other points we need to understand from this? What are the inputs and outputs that we are giving? Okay, this is a very important concept, I can say, because whenever you are doing the testing, or whenever you need to give the inputs to the uh, control desk or canoe, okay, so first input signal is a image signals, okay, image sensor, because the image sensor is a first step where we need to enable the camera. Okay, so that is a coming as a part of the image sensor signal. So once the signal you send, okay, so that time the sensor will be activated, and it will capture the image. Okay, so the image data will be captured with the help of the camera. So if you open your mobile and click on the app, right? So that time what will happen? So it will enable us to see the camera. Okay, so you are able to take the photo or video, anything. Means that is the first phase of the enabling. Means once you took the photo, you can play the video. So that will be considered as a first phase. And the next phase is power supply, because the power supply signal is also one of the input. So we to enable the camera whenever you are taking the image, right? So that time there is a some current or voltage will be utilized to because if you remember, like whenever your camera is at less battery, like 3% or 2% or 5%, it will say that you cannot flash, you cannot take the photo. Means that time whatever if you take one image also, the power consumption is required more. Okay, the voltage also is required more to act on the application, and to processing the data, whatever the image you are taking, to processing that, it requires some power also. Here we require the power supply signal for our ECU. And next is about the vehicle speed, because simply we if we cannot activate the sensor. So when we activate the sensor, the vehicle speed should be required. Okay, so means we need to drive the vehicle, then only the camera it will take the video of with stand. మనకు స్టాండ్ లేకుండా, అంటే కంటిన్యూస్ గా ఒక ఇమేజ్ క్యాప్చర్ కాకుండా మల్టిపుల్ ఇమేజెస్ ని పాస్ చేస్తూ ఉంటది, అండ్ వీడియో అనేది కంటిన్యూటీ రన్ అవుతుంటది. సో దట్స్ అబౌట్ ద వెహికల్ స్పీడ్ సిగ్నల్. And next is steering angle, because steering angle is very important. ఆ వెహికల్ అనేది మనం డ్రైవ్ చేస్తున్నప్పుడు స్టీరింగ్ ఎలా కంట్రోల్ చేస్తున్నాం, వెదర్ ఇట్ ఈస్ ఇన్ కంటిన్యూస్ రొటేషన్ వే ఆర్ ద స్టాండ్ పొజిషన్. సో స్టీరింగ్ ఈస్ ఇట్ గివ్స్ ద డైరెక్షన్ ఆఫ్ అవర్ వెహికల్, అండ్ so that information should be passed to the ECU. Next is coming to the yaw rate. Yaw rate is about the vehicle. So whether what how the vehicle is making the alignment, whether the vehicle is moving in a straight way, or so any hill stations up, or acceleration is forcing on the vehicle. So any curves, during the curves, how the vehicle is forcing, so that will be part of the yaw rate angle. Okay, so yaw rate, there will be the sensor. So how the vehicle is adjusting, how it is stabilizing towards the lane departure warning and adaptive cruise control, it will be considered as a yaw rate. Okay, I will tell you more detail about yaw rate once the section completes. Okay, so braking signal is about so it, because there will be chances during the collision it can occur, right? And you need to read the braking condition also, whether we are applying the brake or it is in a zero brake, or we are likely we applied as a 15. If you consider like zero, I have a brake, it have up to 30. So means that is the range. Mid brake and high brake, okay, and low brake. So when you apply the braking signals, right? So with low, mid, high, so that time the signal will say the braking sensor is at a low. So this is for the sensors. We are reading it, okay, with the help of the sensors. We are reading the braking signals. Okay, and next is about the turn signal. So what is the purpose? So whenever you have the vehicles you need to drive. Okay, suppose your vehicle is driving on the road, you have a car. Okay, so you need to turn the rotation. So when and so during that, if any persons are coming, or you have another road near to this, so this is a part of a small road or small street, you can say. That time if any bikes or anything it is coming, the persons may come. So during that time, the cars are adjust time, how the vehicle will be protecting. Okay, so that is about the turn signal. So it is about the blind spot detection and land change assist. Okay, so because land it is also changing, right? So it won't be in a straight, it will be as a part of the curve rotations also it is forming. So that's about the turn signal, so how it will change the information. And next is about the lightning condition. Okay, so it's related to the temperature. So how the image quality. So you need to adjust the climate based upon the night or dark, anything. So like the mode should be adjusted automatically. How we are adjusting our camera, like portrait and night mode. So similarly, the cameras in the vehicles also, it should be conditionally activated. Okay, so that is about the light conditioning signals. So it will automatically adjusting of the camera exposure setting and rain sensor. So it is about specifically the wiper wash system. So means these are the inputs. So we need to give to the front camera ECU. Okay, so whatever the controller ADAS ECU is there, right? So for that we need to give this many signals, informations. It will be reading it continuously because it is in all network, right? So it's required those information. And GPS is because to know what is the vehicle speed or what is how vehicle we are running in the right direction or not. So that is about a GPS signal. And coming to the output signal, so what are the output signal? Image processing. So once the image is taken from the sensor, how it is processing. So that detection, we it is a part of the output. So the detecting of the object, landmarking, traffic sign, pedestrian, all these will be we're able to see on the car display. Okay, so reading and processing because you have a car and you need to monitor the signals and all those stuff, right? How you are able to do? So the camera is the one, it will process to the controller and the controller will display on the back end. It have a more algorithms and features to process it. Okay, so what that display, you can see the traffic signs, all those stuff on the display unit. And parallelly, the same signals we are giving for the uh, brakes and the engines also. Okay, so that's how the image processing will be happening. And the object detection signal, so it is specifically whenever you get the collision or something. So before getting collision, how you the object whether it is detectable or not. So the car or any trees or houses or anything which is a static or dynamic, means moving or non-moving objects will be detected by the vehicle sensor. And land departure warning. So land departure warning is specifically the car moves within the line, and if any diversion is happening towards the other side, then it will give the warning and acoustic sound. Okay, so acoustic sound will be given. It is like a speaker. You will get some warnings. So like you cross the line with this, stay within the line, like such kind of acoustic sounds will be get it, and warnings it will be displayed on the control unit. Okay, so that's about the land departure warning signals. You will get it. And next is a part of the traffic sign recognition. So like the stop or sign or limit, something you will get it. And next we have the pedestrian detection signals. So next the forward collision warning. And yeah, so that's that and all you will get it as a part of a reading. So suppose your vehicle is moving, if you are a safe zone, you will get it in a green way color. If you are nearer to that, then automatically the emergency brakes will be applied. If it is a